Greet everyone, Masha Allen again, your tutor, your teacher. Today we'll be discussing structural programming using pseudocode and Pascal. This is actually geared towards persons intent to do their CXC, their CAPE, their CSEC in information technology and computer science. Now, I know the topic, structured program, might seem a bit scary, but it's not as technical as big as it seems. It just has to do with a style, a principle in terms of how to write instructions for a computer. If you can recall your lesson in operating systems, that, for example, operating systems, what tells a computer, software that generally tells a computer what to do, when to do and how to do. So this lesson has to do with having a concept of that, how to write instructions for the computer to follow from. Now, pseudocode by definition is an informal high-level description of the operating principle of a computer program or other algorithm. Typically, it is really an English representation of actual programming principles and concepts. Just do it in a way in English that for beginners to understand. Now, we will go into two things, the syntax and the semantics of programming. Now, syntax actually speaks to rules, regulations that govern how things are done. Similar to how in every country you have laws, principles, judicial systems, police, and in a similar way you have principles, laws in just about every programming language. Now, semantics has to do with logics. In simple terms, doing something that makes sense, something that is reasonable, something that at the end of the day is a task that it does something. Refers to meaning of language as opposed to their syntax form. Says on the it's contrary to syntax, it speaks to logics, a paradigm. Now, I shall be guiding you into a pseudocode that I've actually constructed. Definitely for you to look into. Let me bring it up here. Now, here is a program that I have written in pseudocode. Now, let me get over this side to explain more deeply what it's all about. Now I have it sample code that determines whether or not a number is positive or negative. So here, as you can see clearly, that will start. So now, just similar to how you have a store it as a start and also it as an equal ending, in a similar way, every program has a start and it has an ending. Now, here we are defining num as integer. For you to be able to use any variables, and which will be area in memory that you would insert a value for the program to operate from. Before you could actually enter any variable for the computer to understand, you would have to first define it. Similar to how you do story writing, you have to define characters before you actually put them in the story, because you don't have a story. For example, I want to get across here that it has, you virtually have a John Doe that pops up in the story, and at the end of the day, you had no description as to what a John Doe is. It throws things off. Now, here is now the high point of the story here, of the program here, because here is what, this is basically speaking to why the program actually came into existence. This actually speaks to what the program is actually meant to do. So it's actually meant to take the number, and then from here there's a conditional if statement. And then what it's saying that is that if num, which will be this number here, is less than 0, then print this is negative. So it's similar to mathematics. If you can recall maths in second form, anything below 0, negative, anything above 0, positive. It's similar to how you say sub-zero temperature, I mean below 0, very cold. So here, it takes the number and it said if the number is less than 0, then print this is a positive number. Now if it's less than 0, that is, this is a negative number. Now if it is not below 0, then it's either they can be above 0 or the same as 0. And it's saying that if the number is otherwise, in other words, not less than 0, then print the number is positive. Now, taking this into consideration, you see where we have this if statement. And then we have, if you note, we also have equating end if. This is important if, for example, with the if statement, because what? If you're going to have an if, you must have an end. If you have a start, you must have an end. It's just like a 100-meter race. You must have a start point, you must have an end point that we can know where to start from. And this prints to the screen that this is a positive number. I actually have the Pascal version here. Now this is actually the required language for CXC. If it's more like KB, maybe doing a C or Java, which you learn as you progress in the subject matter of IT. Now, I have it here, program this describes the name of it. So I'm saying that Pascal first, that is what I name my program. And similar to how I had declared the variables that define numbers in, I have it here where I actually had, say, var num integer, because this represents what I had before when it says define. So you have define, I said num, I had the colon here, I said integer. Similar here, I have a begin, I have a start. Of course, Pascal is begin. I also have equating ending. Now, importantly, no, this wasn't in the original pseudocode, but you would have, I have a write statement that says, please enter number / integer. So this actually prompts the user to enter the number into the field. So it prompts the user that please enter number, and then right here it gives the user the opportunity to enter the number on the keyboard. And then similar to our pseudocode example, we had the if. And we're saying that if the number is less than 0, then print this is a negative number. Instead of having an else, I just wrote a second if. And I said that if it's equal, greater than or equal to 0, similar to maths, then print this number is a positive number. We find that there's a slight difference here because we had a if and then we had a second if instead of having if else. And we had a begin and end in between here. That is just a slight difference between pseudocode and Pascal. That's why I said to you that the principle remain the same. And this is why I delved into pseudocode, which we'll be doing in other lessons, because the principle remains the same in just about every topic. You're using if, you must also have an equating end if. Coming back here, you must be able to enter the number into the console that the student could actually enter the variable into the system, that there can be an input to receive the value, and then it receives the value, then it then has to decide that here num less than 0, this is a negative number, or else this is a positive number. And this is my basic lesson in pseudocode. So we discussed the principles of programming, the syntax, the semantics of programming. Of course, that syntax speaks to rules that govern how things are done. Semantics, something that makes sense, is logical, because this program makes sense, right? Yeah. So virtually, this is what it is. Don't say yes because I say it. Because if it don't make sense, feel free to say it. I would define what pseudocode is. Of course, Pascal is a language that was actually developed virtually because many scientists, they were not professional engineers, so they had to develop something that was easy to use. And this is my lesson in structural programming, pseudocode. Thank you.
All right.